All right, so to get started with section 4, we're going to break this apart again into two separate sections just because, like with the ellipses, we have hyperbolas, which is what we're going to talk about, that are centered at the origin, and then we have some that are not. Now, just like with ellipses, you're going to have charts that kind of help guide your process through, like figure out the points that you need to graph. And some of the points are going to be the same, like we're still going to have vertices, co-vertices, foci, but then we're also going to switch it a little bit because hyperbolas look a little bit different than ellipses do. Hyperbolas, look like these two types of graphs right here. So they're made up of, we call them branches. The branches are like the two different parts of the graph. They're not connected, so they don't have any common points together. And they're reflections of each other. So the one down on the left here, they're both opening up kind of on the x-axis. And you can see that one is like opening up to the left and the other one's opening up to the right. But they look the same. They're like one has been reflected over that y-axis. Now the same thing happens if it's a vertical hyperbola. It's just your branches are in a different spot. So like the first one's up on the top and then it gets reflected over the x-axis and it's facing down now. So this is what these are going to look like. And again, if we look at our charts down here, this will tell you like which one is which as far as do they open to the left and to the right, or do they open up and open down. So again, I gave you guys that formula sheet. This would be information that you should try to fill out at some point in time, just so that you have it all. Okay, similar to how it was with ellipses when you're looking at these first ones. Like I said today, we're only going to focus on hyperbolas that are centered at the origin. So they're centered at 0, 0. So you can see x squared over y squared, and then it's got a minus sign, y squared over b squared. And again, a has got to be the bigger number, so that's staying the same as well. So if you want to write yourself a note there, that a is always the larger number. Because that tells you which side of the chart you're going to be working on. So if x is over the a term, the bigger term, then we're going to use the left-hand side, which means that it's going to be a horizontal hyperbola. So it's going to look like the one up above on the left. So this one goes with that graph there. And then if y is on top of the a, so if the a squared is still the biggest number and y is sitting on top, it switches the way that our hyperbola is, becomes vertical, so it matches the other one that I had up there. Now, if you guys notice here, it says c squared equals a squared plus b squared. That is not a typo this time. Okay? On ellipses and on circles, we had to change it to a squared, or I think it was a squared minus b squared. For hyperbolas, we do keep it plus, only because the foci points go farther than the vertices do. So it's going to be a little bit different in just that those points, instead of being like on an ellipse, you guys would graph your vertices and the foci would be getting close to the vertice. This time the foci are going to go past it for hyperbolas. So that's why we have a plus sign there. Vertices, co-vertices, and like I said, the foci are all pretty much the same as they were for ellipses that are centered at the origin. One extra thing that we have is the slope, and I'll show you guys what this means a little bit when we get into some examples. But your equation to find slope would be the number under the y, you put that in the square root, and that's over the number underneath the x. So again, you'll have to look at your equation, and you'll have to find your x squared and your y squared terms, and you'll just take the number that's underneath it and put it in there. Now the reason why we're adding that piece in is because we're going to have these lines called asymptotes, which we've talked about in the past. When we graphed rational expressions, so when you were graphing something like 2 over x plus 5, we had to find asymptotes for that. We had to find like the values that just didn't work for the graph, and we drew those as dotted lines. They were kind of like boundary points for our graph. We still have those for these hyperbolas. There's still going to be points out there that we just couldn't have be put in for our x and our y values because it would cause issues if I were to start typing it into my calculator. All right, so let's turn the page over, and we're going to do one of these together here. So this first one says we have x squared over 16 minus y squared over 25 equals 1. So again, the first thing I'm going to do is identify my a and my b. So remember, a squared is always the larger of the two numbers on the bottom. I'm looking at the 16 and the 25. So 25 is my a squared, which means that b squared is 16. So to find a and to find b, we just square root those. So a is going to be plus or minus 5, and b is going to be plus or minus 4. So if I'm going back over here to my chart, I'm looking at the right-hand side because the y squared is over the 25, which is the bigger number. So I'm going to be using the vertical hyperbola part of my chart, which is the right-hand side. All right, so let's go ahead and find our c squared. So this is when we're going to add our numbers together. So we're going to do 25 plus 16, which is 41. And so I'm going to need just regular c. So again, we're going to square root that c squared, which we found to be 41. And like what happened with ellipses, most of the time here, you're probably going to get a decimal. It's possible to get a whole number because there is chances of you getting a number that is able to be square rooted. But like this one, I'm going to have to round it. So this one is about 6.4. So plus or minus 6.4 there. All right, so let's start identifying like our vertices, our co-vertices, and our foci. Now remember, these are all centered at the origin, so if you need to, you could always just put down that your center is 0, 0. Now vertices. Vertices on the right-hand side says that we do 0 and then plus or minus our a value, which we found up above here to be 5. So again, to write those out as two coordinates, we would have one be at 0, 5, and the other one would be 0, negative 5. Now, co-vertices. Co-vertices, according to my chart, says that we do plus or minus b and then 0. Yeah. So our b is 4, so we're going to do plus or minus 4 and then 0. So we would write that out as 4, 0, and then negative 4, 0. And then the last thing I have is my foci, which is going to be 0 plus or minus our c. So that would be 0 plus or minus that 6.4 that we found. So again, two coordinates there would be 0, positive 6.4 and 0, negative 6.4. Okay, so I could start by graphing these things, and I will in just a minute, but there is one extra thing that we need to add on, which is finding the slope, okay, for those asymptotes, for those dotted lines that we're going to have to draw in, which kind of gives us boundaries for our branches that we know they can't cross those points. So to do that, to find your slope, this is at the bottom of your chart, and it's the same for either side that you're working with. You do the square root of the number underneath the y over the square root of the number over the x, or under the x. So coming back up here to our equation, the number underneath the y is 25, so we're going to do the square root of 25 over the square root of the number underneath the x, which is 16. So it's going to be 25 over 16, which would be 5 over 4, plus or minus 5 over 4. So let me show you how to graph these. So we've got everything that we need here. So I'm going to go ahead and draw my graph in. So center's at 0, 0, so the origin there. My vertices, one of them is at 0, 5, the other one's at 0, -5. So remember, this one we said was a vertical hyperbola, which means that our branches are going to be opening up and opening down. It's going to match the right-hand picture. So it's going to look like this one here. Okay? So when I do 0, 5, that means you go up 5, and you go down 5. Now my co-vertices are 4, 0, and -4, 0. So we're going to go left and right 4. So now my slope is this 5 over 4. So what that means is that my asymptotes, like if I start at 0, 0, I would be going up 5 and over 4, up 5 over 4, or I would be going down 5, left 4, down 5, left 4 to get those two lines. Now you can do that, but the problem is that you're going to have limited space, so you may not be able to do a whole bunch of those points, or if the numbers are really big, it's going to take a while to actually see where the point is at. So here's a little trick that you guys can use. Those 4 points that we just drew with the vertices and the co-vertices, I'm going to draw like a little box, like a rectangle that connects them, and I'm just going to keep it as a dotted line. Okay? And so what I do here, and this is when you might want to use like a straight edge, so get like your lunch card out, a card from your wallet. If you have a ruler, that's great. But if not, use something that you, like an edge of a notebook, edge of a binder, anything that you have. And what I would do is lay them from diagonal to diagonal, like corner to opposite corner on this rectangle, and draw in those asymptotes. Okay, so one of mine is going to go this way. They should go through the center. So there's one, and then we're going to draw the other one in. What these lines, those dotted green lines that I have up there, tell us is that my branches have to stay within those dotted lines. Like they cannot, I can't have these branches just go wild and crazy and go outside wherever they want. There's still some boundaries on them. There's still some values out there that don't work for this equation. So to draw in my branches now, because this is a vertical hyperbola, you're going to go up to the vertice, which remember was up here at the top. This is a vertice and this is a vertice here. And you're just going to do a rough sketch. It doesn't have to be anything fancy or perfect. So from the vertice, we're going to just open up and we're going to open down. Like I said, we don't have like specific points that we're graphing there. We're just kind of going to do that curved shape for that branch. The last thing I'm going to graph on mine is my foci points. Remember I said that for hyperbolas, the foci goes beyond the vertices. So your vertices were at 5 and -5 on the y. So your foci is 6.4. So you're going to go up 6.4 and down 6.4. And again, if you want to label it with like an F, like we've done in the past for those foci points, you can. You can do that also with those co-vertices, just like I did with the vertices. You don't have to label them, but if that's helpful for you to kind of remember, you know, where everything was at, and I can see how they're connected, then you can absolutely do that, but it's not required. All right, so I want you guys to take a look at number 2 here, and try to do as much as you can of this problem. Okay, your a squared for this one is 20. Your b squared is 18, because 20 is bigger than 18. Now when you square root these, both of them are going to come out to be decimals, and that's okay. So the square root of 20, for just our a, is going to be around 4.5. And then the square root of 18 is going to be a little bit less than that for b. That's going to be about 4.2. Now, the larger number 20, the letter above that is the x squared. That means that I'm using the left-hand side of my chart. So this is going to be a horizontal hyperbola, which means that the branches will open up to the left and they'll open up to the right. So it'll be opposite of what the last one looked like. To find your c, start by finding c squared by adding a squared and b squared. So that would be 20 plus 18, which comes out to be 38. So then c would be to take the square root of 38, which is about 6.2. And again, I'm having to round there. So now I'm using the left-hand side of my chart. My center is still going to be 0, 0. Vertices. Okay, if we come back up to our chart for just a second here. So I'm using the left-hand side here. My vertices is the A first, and then 0. My co-vertices is 0 first, and then my B. And then my foci are the same setup as my vertices, like this and this match. So we'll just follow the chart there to fill out these pieces of information. So vertices are going to be your A value, so plus or minus 4.5, 0, which would be positive 4.50 and negative 4.50. Co-vertices should be 0 and then your B, positive and negative. So that would be that positive 4.2 and negative 4.2. For the foci, that should match what your vertices look like. So our vertices, we did our A term first and then 0. So the foci should be your C term first and then 0. That's going to be plus or minus 6.20. Okay, the last thing that we need to maybe state is what the slope is of those asymptotes. So we're going to square root the y term, or the number underneath the y term, which is 18, and the number underneath the x, which is 20. And so this is going to be plus or minus, if I round, like 0.95. Okay, now again, I could leave it as a fraction if I wanted to. Because this point's a little bit harder for us to graph because it's a decimal. Like this means that you have to go up almost 1 and then over 1 and then up almost 1 again and over 1. It gets a little bit hard, and that's why I showed you guys that box, that rectangular box, because then that just allows you to draw those lines in, and it would be pretty close if I actually used the slope there. So now we're going to have to graph all of this stuff. So again, my center is at 0, 0. My vertices are at positive 4.5 and negative 4.5. My co-vertices are at positive and negative 4.2, but those are on the y-axis. Okay, I'm going to draw my rectangle box in now. And then, again, I would use like a straight edge here to help you to draw those diagonals in. So go diagonal, diagonal, like opposite corners on your rectangle. and draw those two asymptotes in. So there's the first one, and there's the second one. So like I said, this is going to be a horizontal hyperbola, so it's going to open up to the left and open up to the right. So from those vertice points, you just need to sketch in what the branches would look like. And again, they're going to have to stay within those green lines, so just make sure you don't try to go out too far. You want to keep it within that. Those are like those boundary points. Last thing I'm going to graph are my two foci points. And there we go.